Hi everyone, welcome to Unit 31 of online course on probability distributions. In last session, we have discussed some numerical examples related with the geometric distribution. And in this session, we are going to consider some numerical problems related with the negative binomial distribution. We have defined negative binomial distribution and we obtained mean, variance, moment generative function, etc. of negative binomial distribution in previous session. And here we consider some numerical problems related with the distribution. And we know negative binomial distribution is actually a distribution representing a discrete random variable, that is number of failures preceding R successes. That is, suppose we have defined x a negative binomial random variable and parameters usually represented by R and P. Suppose x follows negative binomial with the parameters R and P, where R represent actually number of successes and P is the probability of getting a success. So, R is the number of successes and P is the probability of getting a success. We are performing a sequence of Bernoulli trials until we obtain R number of successes. So, that is we started from trials, first trial, second trial, etc. and where we are getting rth success, then we will stop the Bernoulli trials. X failures and R minus 1 success. So, that is before the x plus rth trial, we have R minus 1 success and x failures. So, if it is, what is the probability mass function? That is probability of x is equal to x plus R minus 1 C x p power r q power x, where x is any value 0, 1, 2, etc. and p plus q is equal to 1. Or this is represented in another form, x plus r minus 1 c r minus 1 p power r q power x. Both are the same representation, and that is obtained by NCR is equal to NCN minus R result. So, we can represent probability mass function of negative binomial distribution like x plus r minus 1 C x p power r q power x, where x is equal to 0, 1, 2, 3, etc. and p plus q is equal to 1. So, this is the concept behind the negative binomial distribution. And now we are discussing some numerical examples where we apply negative binomial probability mass function in order to find probabilities associated with that model. So, consider an example. Find the probability that third head turned up in 5 tosses of an unbiased coin. So, this is a very simple typical example associated with the negative binomial distribution. We have defined our success as getting head. Okay. And what we are doing, we are performing the tossing of coin, and our aim is to find the probability that third head turns up in fifth toss. So this is our fifth toss of the coin tossing experiment. And here the should be third head. So success is here, the third success is in the fifth trial. So that is before this, that is first trial, second trial, third trial and fourth trial we have. So our R is number of successes here is what? Total number of successes we fixed as 3. So the probability that third head, so R is equal to 3. So we are fixing the number of successes as 3 and that should be in the fifth toss. That should be in the fifth toss means the total trials is here 5. So x plus R is equal to 5. And what is the probability of getting success here? 1 by 2. So what is our probability mass function? Probability mass function, our using the negative binomial concept, it is x plus R minus 1 Cx p power R q power x. And for this particular case, this is x plus R minus 1 means 4. We have the before that, the fifth trial, we have the third head. So before there will be 4 trials. So x plus R minus 1 means 4. Cx, what is x here? 2. X is actually number of failures. So how many failures should be? So if this should be third head, there should be 2 heads and 2 tails in the first 4 trials. So our number of failures is 2. P power R, P is here 1 by 2. Here R is equal to, it is P, R is number of successes 3 and Q is also 1 by 2. Power x, what is x here? 2. Or combining this factors, it is 4C2, that means 4, it is 4C2 1 by 2 power 5. So when we are tossing a coin and suppose our getting head is termed as our success and it is an unbiased coin, so probability of getting success is 1 by 2. Find the probability that the third head turn up in the fifth toss. It is similar to the modeling aspect of the negative binomial concept. What is negative binomial? We are performing Bernoulli sequence until our successes are obtained in a Bernoulli sequence of independent trials with a probability of success P. So this is a situation. So what is the probability value of third head turn up in the fifth toss? It is 4C2 1 by 2 power 5. So this is a simple example where we are applying negative binomial distribution. So this is the value. So P is equal to 1 by 2, R is equal to C, P is equal to 1 by 2 means it is an unbiased coin, so Q is also equal to 1 by 2. Okay. And number of success, how many successes we have? 3. And how many trials we have? 5. Because our aim is to find the probability of getting 3 heads in the fifth toss. So x plus R is equal to 5. That means number of failures preceding that is 2. So x is equal to 2. So what is the probability mass function? 4C2 1 by 2 power 3, 1 by 2 power 2, and this is combined as 4C2 1 by 2 power 5. So an example where we are applying negative binomial probability model to calculate the probability value. And another example similar to this, suppose we have a problem of when a chess player plays chess against his favorite computer program, he wins with probability 0.60 and loses with probability 0.10. and 30%, that is 0.30 for the draw. That is, the result is become a draw in 30% cases. So, if this is the model we have, or this is the practical situation we have, and assume the independence of trials of the game, find the probability that his fifth win happens when he plays his eighth game. See, the problem here is a chess player plays chess against the computer program, and he wins with the probability 0.60. Okay, the probability of winning the game is 0.60. So, probability of not winning the game is actually, we need the complement part of that, it is 0.40. We are not bothered about other aspect, whether it is draw or whether it is a loss. So, only thing is the probability of not winning the game is 1 minus 0.60, that is 0.40. And if we are assuming the games are independent, find the probability that his fifth win happens when he plays his eighth game. See, so that is the fifth win happens in the eighth game. So, this is the event we have, and we are actually finding the probability of this particular event. And what is given to you? The probability of winning the game is 0.60, and not winning the game you take as 1 minus p, that is 0.40. Okay. So, if it is, what is our problem? Find the probability that the fifth win happens when he plays his eighth game. So, that is, we know, suppose the negative binomial distribution is considered, our R is what here? R is number of successes. So, fifth win, that is, number of successes is 5. And R is equal to 5, and what is X or X plus R? X plus R means total trials, that is in the eighth. So, actually we have a random variable that follows negative binomial with R is equal to 5 and X plus R is equal to 8, or X plus R is equal to 8 means X is equal to 3. Okay. So, X is equal to 3. So, X plus R minus 1, our problem, X plus R minus 1 C X P power R Q power X is our f of X. So, if this f of X is, if we are finding the f of X value, this is equal to X plus R minus 1, that is 7C, 7Cx, X is 3 here, 7C3, P is 0.60, power R is the number of successes, that is 5, and Q is our 0.40, and that is power X is equal to 3. So, probability of winning the game, the fifth success happens in the eighth game is equal to 7C3 0.605 power 5 into 0.40 power 3. So, this is an example where we are applying negative binomial probability model to calculate the probabilities. Okay. So, next example you consider, an item is produced by a machine in large numbers. the machine is known to produce 10% defectives. A quality control engineer is testing the item randomly. What is the probability that at least three items are examined in order to get two defectives? So, go through the question once again. An item is produced by a machine. Items are produced by a machine in large numbers. The machine is known to produce 10% defectives. A quality controller is testing the item randomly. What is the probability that at least three items are examined in order to get two defectives? So, here the problem is in order to get two defectives. So, our problem is number of successes is fixed. So, success is our getting defectives. Let me define our success as defective, getting defectives. Items are produced by the machine and our success is termed as getting defectives. And our interest is to get the number of success is 2 and at least 3. See, the problem is at least 3 items are examined. At least 3 items are examined means we have to examine the items x plus r at least 3 times. So, x plus r is greater or equal to 3. So, in that case, x plus r is the total number of trials and x plus r should be greater or equal to 3 and that means r is equal to, and what is our p is given to you as what is the probability of machine is known to produce 10% defectives. So, 10% defective in p is equal to 0.01, 10% defectives. So, our problem is to find the probability that this x plus r is greater or equal to 3. And probability of x plus r greater or equal to 3 means what? Probability of x greater or equal to 1, because you have the fixed r is 2. So, x plus 2 is greater or equal to 3. So, probability of x greater or equal to 1, and probability of x greater or equal to 1 means you take the complement 1 minus probability of x is equal to 0, 1 minus probability of x is equal to 0. 1 minus probability of x is equal to 0 means it is 1 minus 0.01. Is it? I think the probability value is 10%. So, sorry. So, 10%. It is 10%, that means 0.10. Okay. So, (0.1), that is our probability. Probability of x is equal to 0 is 0.1, and that is x plus x plus r minus 1 c x p power r q power x is our probability value. So, x is equal to 0 means r minus 1 0, that is p power r q power 0, that is p power r, that is equal to 0.10 the whole square. So, this is the value. So, 1 minus 0.1 the whole square is the probability of x greater or equal to 1 using the negative binomial probability mass function. So, that is we are verifying at least 3 items in order to get r number of successes, and r is fixed here 2. So, our problem is find the probability of x plus r greater or equal to 3, and p already you are given that p is equal to 10%, and the probability of x plus r greater or equal to 3 is the required probability. that is it is equal to probability of x is greater or equal to 1, that is 1 minus probability of x is equal to 0, and probability of x is equal to 0 is obtained from this probability mass function. Here x you take is 0. So, when x is equal to 0, this value become p power r, that is 0.1 power r, and r is equal to it is 0.1 square. So, this is the probability value of verifying at least 3 items in order to get 2 defectives. This probability value is equal to 1 minus 0.1 the whole square. Okay, this is the case. And a numerical example you consider. Again, it is the case where we are applying negative binomial distribution. It is the 10% of applicants for a job possesses the right skills. So, only 10% of applicants for a job possess the right skill of that profession. A company has 3 positions to fill, and they interview applicants one at a time until they fill all 3 positions. What is the probability that they will interview exactly 10 applicants? And second question, what is the probability that they will interview at least 5 applicants? They will interview exactly 10 applicants. What is the probability that they will interview exactly 10 applicants? And how many positions are there? 3. See, so our R is here 3. Why? Because success, number of success is fixed. That is 3 positions are there. And R is equal to 3 is our value. And probability of getting success is 10% of the applicants. So, 10% means 10 divided by 100 or 0.10. Okay. So, P is equal to 10% is given to you, and R is the number of successes, and how many positions are there? 3 positions. The company is interviewing applicants until they fill all 3 positions. So, that is R is equal to 3. And the question is exactly 10 applicants will be interviewed. So, that means we have to fix the x plus r is equal to 10, and that is our f of x, the formula of f of x is x plus r minus 1 c x p power r q power x. This is the probability of getting the third success is obtained in the 10th trial is obtained by probability mass function x plus r minus 1 c x p power r q power x, and that is substituting the values. X plus r minus 1 means there will be 9, and c x is here, c r is equal to 3. So, x plus r is equal to 10 means x is equal to 7. So, x plus r minus 1 c x p power r, p is here 0.10, and that is power r is equal to 3, and q that is 0.90, okay, 0.90 power, and x is here 7. So, 9 c 7 0.10 power 3 into 0.90 power 7. Simplifying that expression, this value is equal to probability of interviewing exactly 10 applicants in order to fill 3 positions. And this 9C7 can be written in x plus r minus 1. This can be written in another form also. So, this is actually 9C2 also, that way also we can write. So, both are same. So, calculating these values will get the probability of the corresponding event. And then the second part of the question is actually what is the probability, see the before we have, what is the probability that they will interview at least 5 applicants. So, that also we have to find. They will interview at least 5 applicants. They will interview at least 5 applicants means x plus r greater or equal to 5. Okay. So, they have to interview x plus r greater or equal to 5, and already we have r is equal to 3. So, that means probability of x plus 3 greater or equal to 5, that is probability of x greater or equal to 2. Probability of x greater or equal to 2 means what? 1 minus probability of x is equal to 0 or 1 by taking the complement part of the probability, and that is 1 minus probability of x is equal to 0 plus probability of x is equal to 1. And this probability of x is equal to x, we know it is x plus r minus 1 c x p power r q power x. This is our binomial probability mass function. So, on the basis of that expression, you substitute the corresponding values, r is equal to 3 and x is equal to 0 and x is equal to 1, you will get the result as this is 1 minus probability of x is equal to 0 means 0 point p is here, the value of p is equal to 0.10 is given to you. So, 0.10 power 3 is the value corresponding to probability of x is equal to 0 if we are substituting x is equal to 0 in this expression, plus probability of x is equal to 1, that is obtained when you are substituting x is equal to 1 here, and this is 3, 0.10 power r is again 3 and 0.90. 0.90, that is okay. So, when we are substituting x is equal to 0 and x is equal to 1 in this expression where r is equal to 3, we will have the probability value. So, if we are finding the probability of this particular event, that is what is the probability that they will interview at least 5 applicants, that was the answer. So, that is we have the first part, we have this answer, p is equal to 0.10 is given to you, r is equal to 3 is fixed, and we are interviewing 10 applicants. So, x plus r is equal to 10, and probability mass function value x plus r minus 1 c r minus 1 p power 3 q power 7, or we can write in another form x plus r minus 1 c x p power 3 q power 7, and substituting the value you will get the probability of that particular event as like this. Okay. And then second part of the question, we have to interview at least 5 applicants. So, that is the part. Probability is given as 0.10 and r is equal to 3 positions are there, and we have to interview at least 5 applicants. So, x plus r greater or equal to 5, and probability of x plus r greater or equal to 5 means x plus 3 greater or equal to 5, and substituting all the values you will get the second, and this value is equal to 0.9963. After simplification of this expression gives the value 0.9963, and so this type of questions we can answer using the probability, negative binomial probability model. And so, we will discuss some more numerical examples in the next session. Thank you for listening to this session. Thank you.